The moon is over 238,000 miles away, while the deepest point in the ocean, the Mariana Trench, is just under 7 miles down. So why do we avoid the deep ocean more than the final frontier of space? Well, it turns out our own planet holds mysteries that are just as challenging, if not more so, than outer space. Let's start with the most obvious hurdle: pressure. Imagine the weight of 50 jumbo jets stacked on top of you. That's the kind of crushing force you'd experience at the bottom of the Mariana Trench. For every 10 meters you descend, the pressure increases by 1 atmosphere. At the bottom, it's over 1,000 times the pressure we feel at sea level. Building a submersible that can withstand this is an incredible engineering feat. A tiny crack, a microscopic flaw, and the vessel would implode in an instant. In space, the challenge is the opposite of vacuum. But we've gotten pretty good at building pressurized containers, like spaceships and spacesuits, to handle it. The deep ocean's pressure is a far more brutal and relentless force. Next, there's the darkness. Sunlight only penetrates the ocean to about 200 meters, an area called the sunlight zone. Below that, you enter the twilight zone, and by 1,000 meters, you're in total, absolute darkness. It's a blackness more profound than the darkest night. Exploring this pitch-black world requires powerful, specialized lighting. But even with the best lights, you can only see a few feet in front of you. It's like trying to explore a massive unknown city at night with just a single flashlight. Compare that to space, where stars, the sun, and the moon provide plenty of light for our cameras and telescopes. We can map distant galaxies, but we can't get a clear picture of what's just a few miles beneath our feet. Then, there's the communication problem. Radio waves, which we use for almost all our long-distance communication, including with astronauts in space, don't travel well through water. They get absorbed very quickly. So, to communicate with a deep-sea submersible, we have to rely on sonar, which uses sound waves. It's slow, it's not always reliable, and you can't send high-definition video feeds or large amounts of data quickly. We can get live HD video from Mars, but getting a clear, real-time signal from the deep ocean is a massive technical headache. It's like being forced to use dial-up internet in an age of fiber optics, and let's not forget the environment itself. The deep ocean is incredibly cold, often just above freezing. This puts a huge strain on equipment and any potential human occupants. Plus, salt water is extremely corrosive. It eats away at metal and electronic components over time, meaning submersibles require constant, expensive maintenance. Space is cold too, but it's a more predictable kind of cold. The deep ocean is a corrosive, high-pressure, freezing cold soup that is hostile to just about everything we send down there. So while we dream of colonizing Mars and exploring distant stars, a vast alien world remains right here on Earth. The deep ocean is a realm of immense pressure, total darkness, and bizarre creatures that look like they're straight out of a sci-fi movie. We've mapped the entire surface of the Moon and Mars in high resolution, but over 80% of our own ocean floor remains completely unexplored and unmapped. It is a powerful reminder that some of the greatest adventures and most profound discoveries are still waiting for us. Not in the stars, but in the mysterious depths of our own blue planet. Thanks for watching. If you found this as fascinating as I do, don't forget to hit that like button and subscribe for more deep dives into the world's biggest mysteries.